How are you? How is your holiday? I hope you're well. We continue from where we left last time, and today we start on calculations. That is our number 5 area that is tested in paper 3. And just to remind you on the other 4 areas that are tested in paper 3, in question 1 and 2 on titration, enthalpy change, solubility or reaction rates, we talked of completion of tables, use of decimals, accuracy, principles of averaging. So today we start on the 5th one on calculations, and in those 4 areas, that is titration, enthalpy change, solubility and reaction rates, we have calculations. And this is another area that will give you so many marks. So there are 2 things that we check on calculations, and the first one is on the transfer of values. Those are the values that you get from, for example, the table that is filled, and like on titration, the values that you get after you calculate the average. So we have the transfer of values. From where you calculate them, you are supposed to transfer them as they are. So the first point here is values got from the data collected must be, the word is must, be transferred exactly as they are. That is, rounding off is highly discouraged. So those of us who likes rounding off, you should avoid this one as much as you can if you must achieve accuracy. Number 2, we have rounding off. Modality values should be rounded off to at least 3 decimal places. However, to achieve accuracy, rounding off is highly discouraged. So again, we go back to point number 1, that if you want to achieve accuracy, avoid rounding off as much as you can. There are those calculations that deal with the calculation of RFM, or the relative formula mass, and also the RAM, the relative atomic mass. If you will achieve accuracy, then avoid rounding off. The other point is that volumes should not be rounded off at all. For volumes, avoid rounding off. For the number of moles, you should round them to at least 4 or 5 decimal places. And again, from experience, even though you have been allowed to at least 4 or 5 decimal places, I would advise you, please avoid rounding off as much as you can. Transfer the values as they are. That way, you'll be sure that the answer that you'll get at the end of it all will be the most accurate answer. Next, we have number 6 on correct units. The units used when recording the data and when writing the final answer must be correct. For example, volume in centimeters cubed and solubility in grams per 100 grams of water. Correct units must be used. If you use incorrect units, you are penalized and no mark is given. So you should learn on the various units that must be used when you are dealing with paper 3. Next, number 7, we have graphs. Axes, that is the y-axis and the x-axis, must be labeled using the correct units. For example, solubility, the correct units are grams per 100 grams of water. Temperature, degrees centigrade or degrees Celsius. About where to put solubility and where to put the temperature. Solubility is usually on the y-axis, temperature on the x-axis. And how do you know which one is to be on the y-axis and which one is to be on the x-axis? you read the statement, solubility against temperature. The one that comes before the word against should be on the y-axis. The one that comes after the word against should be on the x-axis. So solubility against temperature, solubility y-axis, temperature x-axis. There is no need of you cramming. You just need to understand whatever I have just said. The other thing still on the axis, if you invert the axis, even though you have indicated the correct units, drawn the best graph ever, you'll be penalized. So no inversion of the axis should be there. Inversion means that temperature which is supposed to be on the x-axis, you indicate it on the y-axis. Solubility which is supposed to be on the y-axis, you indicate it on the x-axis. That is inversion. You are penalized. And to avoid penalization, then understand where to put which one. The next point, the scale used must be workable and should accommodate all the points from the data collected. So the scale that you use should be guided by the very many points that you have from the table that you have just filled. So let the many points guide you, such that each and every point will be on a line and not on a space. Like you should not be having a difficult time looking for a certain point where it should be. You should use and be guided by the very many points that you have on the table, such that each and every point should be seen clearly where it is on the graph paper. The next point is that the points plotted should cover 3/4 of the graph paper provided. During Kcse exam, paper 3 chemistry, we are usually provided with an A4 size of a graph paper. So that is an enough space for you to draw the graph. Sometimes you see students drawing a graph that fits a half of the graph paper. That is on the average. They have tried. But still, majority of the points will not be seen clearly. So to be on the safer side, utilize 3/4 of the graph paper. That way you are very sure that majority of the points, in fact all of them, can be seen clearly where they are, without missing any and without having a difficult time searching for any point. So 3/4 is the ideal size of the graph paper. Next, for curves, no ruler should be used. Instead, you should use your free hand. There are those that you know for real, it is a curve, depending on the points that you have been provided with. So there no ruler should be used. Do not get tempted like you want to have a smooth curve and then you first of all join the points with a ruler. That one will lead you to a penalty. So use your free hand. Dotted lines and broken lines should not be used to join the dotted points or the plotted points, that is. So dotted lines and broken lines should not be used to join the plotted points. The word there is plotted, not dotted. So do not use dotted lines. Instead, if it is a curve, use free hand and join all the points. If the graph that you are drawing is to give you a straight line, then for that one you can use a ruler to join the points, because then a straight line is needed. And be neat. There are those of us who goes to the practical room without a rubber. If you don't have a rubber and you keep on rubbing and some of the points are not clear, you miss a mark. So make sure that everything that you do on the graph paper is as neat as possible. Number 2 and B, make sure that you have a title for the graph. For example, a graph on solubility against temperature. Have a correct title of the graph. So we shall continue from there, and we shall still add to the list of the important points that we should know when we are dealing with the paper 3. One thing that you must not forget: write good notes. Write good notes. That is why I have taken my time to copy the major points on the board, and I hope you can see all of them. Write good notes. You'll need them in a few months' time, or in some after some time you'll need them. So I'm wishing you the best. Utilize your time well during this holiday and going forward. Let's meet next time. Thank you.